Hello and welcome to my video, lesson 1.4 on geometric finite series. Series means the sum of every term in a sequence. So we looked at geometric sequence already in 1.3. So here is an example of a geometric sequence where we have a list of numbers. So commas show that it's a list. And between each number we're multiplying. This is what tells us it's a geometric sequence instead of a arithmetic sequence. Okay, and what makes it a series versus a sequence? Well, when we add each term together. When we add every term together instead of just making a list of terms, then it becomes a series. It's the sum of a sequence. All right, so here's our example series. We're going to use it in a moment when we use these two formulas. We're going to be able to use one of the two in our case here. And, well, you could use either one, but let me just show you one at a time. Okay, if we were using, I'm going to start with the yellow one, actually. So maybe I'll use orange to show that. So I'm going to start with the yellow one. Why would I start with the yellow one? Well, because I have this Tn term, which is our last term. So if I have that, I can simply write down everything else. Notice that our R value is to multiply by 3. So 3 times 81 minus T1 is this 1. R, which is the 3, minus 1 down here. And we can either try to start working that out in our heads, or we can begin to plug that in. And straight away get our answer. And you could also, because it's a simple sequence or series, you could also just add all of the terms up together. But you may notice that it might take a little bit longer. In this case, it's probably pretty close to equal, but once you start getting into the bigger series, it will take longer. So, and it begins to become quite tedious, so it's much faster to use these formulas. Let's show the other method now. So if we're wanting to use this other method, what would we do differently? Well, we're still using T1 and we're still using R, but we're using n, which is just the number of terms till the last term. So this is 1, 2, 3, 4, 5. This is the T5 term, so the last term is T5. So all we're going to do differently is T1 is 1 times by R, which is 3 to the n, which is 5, minus 1. And then R minus 1, so 3 minus 1 still at the bottom. Okay, and if we plug all that stuff in, well, we're going to get the same value, but let's just plug it in anyway, just so you can see what that looks like. And I sure hope that we have the same answer. All right. And you may notice that it says this R cannot equal 1. Well, because if R was 1, we would have a denominator of 0 in both cases. So that is why we can't have an R value of 1. Because if you think about it, if R was 1, it'd be 1 plus 1 plus 1 plus 1. It's not really a sequence in the same way, right? It's just adding 1 plus 1. So pretty boring. Okay. So this is a finite series. Okay, this is the formula for the finite series. And they're really actually both the same formula. Going from one to the other is possible, going from this one to this one, because of our Tn equals T1 times R to the n formula that we got in the last topic in 1.3, where we were looking at geometric sequences. So because we have this, we can sub in this stuff for Tn here, and that's how it becomes the other one. So if you're curious, that's how one becomes the other. Okay, so we have these two different formulas. Where's my mouse here? Here it is. We have these two formulas. If you could try right now to solve the following two series. Actually, I made this one I made it kind of differently than what I wanted. Let's do this slightly differently. Let's go with T14 and make that a subscript. There you go. So that should work out, right? Yeah, okay. So we have these two different series, and go ahead and try to solve both of them. Press pause when you're ready, and I will try it out right after. All right, hopefully you had a chance to try it out. If not, make sure you pause it, try it out yourself, and see if you can solve it. I'm going to actually go like that, give myself a little bit of room to work with, but not too much. All right. Okay, so find the sum of the following series. So we have to pick which of the two equations we want to use. And how do we know? Well, we know because we have the final value. Because we have the final value, we want to use this formula, the yellow one. So with that in mind, Sn equals R, which is times by 5 in every spot. Okay, so R, so 5 times by Tn, which is our massively massive number. This is going to be a really big number, by the way. Hopefully it's going to fit in our calculator. Minus T1, which is 2, over R minus 1, so 5 minus 1. So here we have, let's plug it in our calculator, so 5 times 781,250 minus 2, 5 minus 1, and yeah, it fits, perfect. All right, so we have a pretty big number here, almost 1 million. Okay, and our next equation, because we do not have that last number, but we do know how big the n is, we don't have it, but we do have the n down here, we can use the blue equation. So Sn equals T1, which is 6. Okay, and every time we multiply by a -2. I hope you notice that. So -2. So we're multiplying by a -2. So that would be our R value, -2. And the n is 14 minus 1. -2 minus 1 on the bottom. So we have -3 down here. And we have, well, we have a big number. So let's actually just plug it in our calculator. Just wonderful that we have amazing calculators like this. Minus 1, -2 minus 1. Okay, so negative 32,766. All right, so hopefully this helps you understand a geometric finite series a little bit better, and give you a little bit of, first of all, the two formulas, as well as some examples that you could benefit from. Hope this video helped, and good luck.